AP Calculus BC, Unit 5, Day 4, Office Hours. So it's just another worksheet to get some more practice on these kind of problems. Some new, some old. So partial fractions is just decomposing. So we're not actually doing calculus here, you're just using that algebra technique of breaking them up. The answers are here. I'll just show them to you real quick. Pause it. You should have checked them already before this. You should have tried all these, but here are the answers. Pause it. Here are some more answers. So I'll put them here for a few seconds. Okay, and let's see. Got a couple more on the back. Pause it. And I do want you to combine the logs whenever possible, because that's awesome. It's generally the way the answers are going to be on multiple choice assignments. Okay, so these first ones we're just practicing decomposition, breaking them down. So you want to factor the denominator, because that'll be the new fractions. X plus 5, x minus 2, so it's going to be x plus 5, x minus 2, and you put a or b over either one. So we're going to multiply through by the least common denominator, and we get 3x minus 1 equals a, x minus 2 plus b, x plus 5. Use the heaviside approach. We could plug a -5 in, get rid of the b first, or get rid of the a first. Is negative 16 equals negative 7a. So a equals 16 over 7. Okay, and okay, then we're going to plug in 2. And so that would give us 5 equals 7b. So b equals 5/7. And so then our answer, got to write the answer, because you could put a, b somewhere else. It wasn't given to you. So, 16/7 over x plus 5 plus 5/7 over x minus 2. I mean, that's not pretty, but that's fine. All right. Next one, we're going to factor out x squared. So there's a repeated root there. So there's going to be an x minus 1. There's going to be an x, and then you're going to also need an x squared. So that's how we do repeated roots, is you do one with the first power and then you do one with the second power. ABC, it doesn't matter which ones you put ABC over, you just got to be consistent in your work. So we're going to get 2x minus 3 equals a x squared plus b x minus 1 plus c x minus 1. So, I mean, we could plug 0 in to all the x's. And so that would give you -3 equals, that goes away, negative c, so c equals 3. We could plug 1 in to everything, okay? And so we plug 1 everywhere, we get -1 equals, those drop out, and we get a, so there you go, there's a. And then to get b, unfortunately, if you plug in 0, what we're going to do is we're going to have to use both of these. So I'm going to rewrite this 2x minus 3 equals -x squared plus bx, x minus 1, plus 3 times x minus 1. So we're going to plug the a and c values in, and then we can plug in anything for x other than 0 or 1. I don't know, I guess I'll go 2 everywhere. And so that's going to be 1 equals -4 plus 2b plus 3. And so could add 4, subtract 3, and that's going to be 2 equals 2b, so b equals 1. So we have to find b last. Find a or c first, and then the other, and then you got to find b last because you need a or c to be figured out, because you can't get rid of everything else other than b. If you get rid of one of the other ones, it gets rid of b also. So your final answer is going to be -1 over x minus 1 plus 1 over x plus 3 over x squared. Okay. All right, next one. Partial fractions, the degree of the top has to be smaller than the degree of the bottom to do partial fractions. Can we factor this? We can try grouping. Group, take out the GCF, x squared, x minus 2, minus 4, x minus, ooh, grouping works. So we get x squared minus 4, x minus 2. Then you got to factor this one, x plus 2, x minus 2. And so we have another repeated factor. So we have to do a over x plus 2 plus b over x minus 2 plus c over x minus 2 squared. All right. So we could multiply 3 by the least common denominator. 2x minus 3 equals, if we multiply through, we would get x minus 2 squared a plus b times x plus 2, x minus 2, plus c x plus 2. So if we get rid of, plug 2 in everywhere, those all drop out. We get 1 equals 4c, so c equals 1/4. So we could get rid of a and b, or we could plug -2's in everywhere, and that would be -7 equals, this would be -4 squared is 4a. Those both drop out, and so a equals -7/4. But to find b, we can't use that heavy-side approach. So we got to find these first and then plug them all in. So it's going to be 2x minus 3 equals x minus 2 squared times -7/4 plus b times x plus 2, x minus 2, plus 1/4, x plus 2. And so now we need to plug in a value of x, any value other than 2 or -2, but something that's convenient. Like I'm going to go with 3 and plug 3's in everywhere. I mean, maybe we could have picked something else that would have canceled all the fractions. I mean, that could be a option. If we plug 2 in, no, we can't plug 2 in. We plugged 0 in. Let's do that. I'm going to do 0 instead, because I want the fractions to go away, and I think it'll work out. And I suppose 0 is pretty convenient anyway. So you get -3 equals -2 squared is 4 times -7/4, right? So the plus -4b plus shoot, that didn't work. Okay, whatever. Okay, you can plug anything in, but I was trying to make it so the fractions away. I would probably need to do like, I don't know, 6. 6 might have been better. Who cares? We'll just do what we got. -7, add to the other side, get 4. Minus 1/2 equals -4b. So that's 8. That's 7/2 equals -4b. So b equals -7/8. I did it right. But I'm looking at my work and it looks like something's wrong. What did I do wrong? Oh, shoot. Okay, this right here, I messed this one. Negative, when you plug negative 2, it's negative 4 squared is 16. So this should be 7/16. So that's going to mess everything up. 7/16. Um, I'm just gonna bail on that one. I'm gonna see if I can take it. Would 6 work? I think 6. 6. I think 6 could work. I'm gonna do 6. Okay, so that is gonna. I'm just trying to pick something that works really nice. Okay, so that's going to be 12 minus 3 is 9 equals 6 minus 2, 4 squared is 16 times 16. So you just have a negative 7 plus, if plug 16 here, it's 8 times 4 is 32b. And here 6 plus 2 is 8 over 4 is 2. So I just thought, oh, it'd be nice to get rid of the fraction. So this is going to be negative 5. Out to the other side is 14 equals 32b. Divide both sides by 32. B equals 7/16. And then we still got to write the answer. We'll just, let's see if we can just we'll just try and fix it right here. A is negative 7/16, x plus 2. B is positive 7/16, x minus 2, plus 1/4, x minus 2 squared. Okay, so there you go. Okay, so let's see. These ones we're going to actually integrate afterwards. So, I mean, first just check if any other more direct method works before you start trying to do partial fractions. And it doesn't. So we've got to factor this. Plus 4 minus 1. So that's going to be a over x plus 4 plus b over x minus 1. Okay, and then we're going to multiply 3 by the least common denominator. 1 equals a x minus 1 plus b x plus 4. And we can plug a negative 4 in if you want first. It'd be 1 equals negative 5a. So a equals negative 1/5. And we could plug a 1 in. And that'd be 1 equals 5b. So b equals positive 1/5. And so now we can go ahead and rewrite it. I'd put the negative 1/5 in front of dx over x plus 4 plus 1/5 dx over x minus 1. We get negative 1/5 natural log of the absolute value of x plus 4 plus 1/5 natural log of the absolute value of x minus 1 plus c. We could just put the 1/5 in front because it's the same coefficient. So it's like you factor it out and be natural log of x minus 1 over x plus 4 because there's a negative in front of it plus c. So I want to do that. I want to combine these when we can. One other version is you could have brought these in first and you would have had natural log of x minus 1 to the 1/5 over x plus 4 to the 1/5 plus c, or you could write it natural log of the 5th root of the whole thing, x minus 1 over x plus 4. You definitely need the absolute value still. So there's a lot of versions of that you could write, but definitely combine them together. Okay, 5, factor it out, x minus 4. Degree of the top is smaller than the bottom, confirm that. And so we're going to do a over x plus b over x minus 4. Okay, so we multiply through by the least common denominator. And get that. So we can plug a 0 in. Negative 12 equals negative 4a. A equals 3. We plug a 4 in. And we get negative 8 equals 4b, so b equals negative 2. So I'm going to rewrite it. 3 dx over x minus 2 dx over x minus 4 equals 3 natural log of the absolute value of x minus 2 natural log of the absolute value of x minus 4 plus c. Should show up in your work there. So we bring these in. You definitely need to bring these in to combine these. So this is going to be natural log of x squared. We get rid of the absolute values. Or no, sorry, cubed. So we do still need over. This is all inside of a single natural log. X minus 4 squared. So we could make this, we could say absolute value of x cubed over x minus 4 squared. You don't need the absolute values there. So that's one answer. Nice combined answer. You know, I mean, these are answers, but let's combine them. Right? So, I mean, yeah, this is an answer, but we can write a little more. Okay, next one, 2x, x minus 3 plus 1. That works. So it's going to be a over 2x minus 3 plus b over x plus 1 dx. So multiply 3 by the least common denominator. If you want to get rid of the b's nicely, you'd multiply by 3. You put 3 halves in. A little ugly. But this is, that's 12 minus 7 is 5 equals 5 halves a. So a equals 2. And then we plug negative 1 in everywhere. And we get negative 15 equals negative 5b. So b equals 3. Pretty nice answers. So we're going to rewrite this. 2 integral of dx over 2x minus 3 plus 3 integral of dx over x plus 1. So it's going to be 2 natural log of the absolute value of 2x minus 3. But there's a chain rule issue. An extra 2 is going to pop out that we don't want, so we got to divide by 2, which actually cancels that 2. It's perfect. Plus 3 natural log of the absolute value of x plus 1 plus c. So I'm going to bring this inside, and we're going to say this is natural log of 2x minus 3 times x plus 1 cubed plus c. So I mean, we could do that. I mean, we could just put absolute values around the whole thing and say 2x minus 3 x plus 1 cubed. You could do that, and then just do one set of absolute values around the whole thing. That would have the same effect. Okay. 3x, x, they gotta both be negative for sure. A 1 and 2, if we put the 2 here and the 1 here, that gives you negative 5x. So it's gonna be a over 3x minus 2 plus b over x minus 1 dx. So multiply through by the least common denominator. We could plug a, this is very similar to, just the last one. Close. 2/3. So that's going to be negative 1 equals a, negative 1/3 a. So a equals 3. Plug 1 in. Get negative 2 equals b. So we're going to rewrite it. 3 integral of dx over 3x minus 2 plus, minus 2 integral of dx over x minus 1. So it's going to be 3 natural log of the absolute value of 3x minus 2. You got a chain rule here. You got to divide by 3. You do U-Substitution if you want, but it seems like a lot of work. 2 natural log of the absolute value of x minus 1 plus c. So we can bring the 2 in, say natural log of the absolute value of 3x minus 2 times, we can drop the absolute values in this guy because you're getting squared. Oh, it should be down here, x minus 1 squared. All inside one natural log plus c Don't forget the plus e. So there you go. That's good practice. Okay, we could try grouping. You could try rational root theorem if you want, but let's try grouping real quick. Every once in a while it works. Hey, it works. Keep factoring. So we have a repeated root. So this is going to be a over x plus 2 plus b over x minus 1 plus c over x minus 1 squared. So that's how we deal with repeated roots. Special case. So we multiply through by least common denominator, so we get 2x minus 3 equals a x minus 1 squared plus b x minus 1 x plus 1 plus c x plus 2. Usually on these repeated roots ones, you're going to have to do something a little weird. You're not going to be able to get rid of one of the variables. So let's get rid of the ones we can. So if we plug in, I miswrote this. Okay, so if we plug in, say, -1, we get -5 for a. That goes away, that goes away. So a equals -5/4. Did I miss that? Why did all my 2's become 1's? 2, 2, 2, 2. So I need to plug in -2. Okay, so that's going to be -7. And that's going to be 16a. So that's going to be -7/16. And then we could plug in a +2. And we would get 1 equals, that one goes away, that one goes away, 4c. So c equals 1/4. And then we're going to plug the a and the c values in here to help us find b. So if, let's see, 2x minus 3 equals a. Okay, a was -7/16. X minus 2 squared plus b, x minus 2x plus 2 plus c. C is 1/4 x plus 2. So now let's plug whatever value you want in for b. I don't know. I'm trying to see if I can get rid of these denominators. If I plug 2 in here, it can't be 2 or -2 anyways. If I plug 0 in here, it doesn't work. So if I can get a 16, it'd be like come from a 4 squared. So maybe plug in a 6 in. And then over here, that would give you 8/4. The fractions would go away. Not that you have to do that. So 12 minus 3 is 9 equals, that's going to be 16. That's going to be -7 plus, that's going to be 16b. Wait, no, not even that. It's going to be 4 times 8. It's going to be 32b. And then that's going to be 8/4 is 2. So it's -5. It's 14 equals 32b. B equals 7/16. That'll work. Okay. So go back up here. It's going to be -7/16 dx over x plus 2 plus 7/16 dx over x minus 1 plus 1/4 dx over x minus 1 squared. This is going to be a power law, right? So this is the same thing as x minus 1 to the -2. So we're going to get negative 7/16 natural log of the absolute value of x plus 2 plus 7/16 natural log of the absolute value of x minus 1 plus 1/4 x minus 1, bump it up, divide by the new exponent, plus c. We can combine the natural logs. And so we just leave the 7/16 out front and be x minus 1 over x plus 2 minus 1 over 4 x minus, why am I? I don't know what's going on here. Okay, so that works. It's kind of messy one. All right, long division. If the degree of the top is bigger or equal than the bottom, you can't do partial fractions yet. You got to do long division. So long division, we're going to do x squared plus 0x plus 2. Any missing terms, it makes it convenient to put them there with zeros in front. Divided by x plus 2. Start with these guys. It's going to be x multiply x squared plus 2x plus, that's it. So we subtract these. We get negative 2x plus 2. And we could do it again. So x goes into that, minus 2 times, negative 2x minus 4, subtract. And the remainder is 6. So that's going to be a fraction. So that's going to give us x minus 2 plus 6 over x plus 2. And now we can integrate it. So it's going to be x squared over 2 minus 2x plus 6 natural log of the absolute value of x plus 2 plus c. Next one, the degree of the top is bigger or equal to the denominator. You gotta start with long division. So that's going to be x squared plus 0x minus 4 divided by x minus 1. So it's going to be x squared minus 1x. Subtract 1x. Drop the next term down. X into x is 1. Subtract. That's the remainder. So we get x plus 1 minus 3 over x minus 1. So we can get x squared over 2 plus x minus 3, natural log, the absolute value of x minus 1, plus c. Okay. All right. If you try and decompose at the beginning, you're going to get it wrong. Don't decompose at the beginning. Don't do partial fractions. Okay, so degree of the top is equal to the bottom, so you still have to do long division. So that's going to be 3x squared plus 0x minus 10 divided by x squared minus 4x plus 4. 3x squared divided by x squared is 3. Distribute, get 3x squared minus 12x plus 12. And subtract the whole thing. Get positive 12x minus 22. This is your remainder because it is now degree less than the original denominator, so you're not going to be able to break it up anymore. So what we have now is we have 3 plus 12x minus 22 over x squared minus 4x plus 4 dx. Now, here's the deal. This guy, if you try to use substitution, doesn't work. So we're going to have to use partial fractions now on this. So let's see, x minus 2, x minus 2. So not just partial fraction, but repeated. So this is going to equal a over x minus 2 plus b over x minus 2 squared. So we multiply through by the least common denominator. It's going to give you 12x minus 22 equals a x minus 2 plus b. Can't get rid of b. You can get rid of the a. That's what you guys start with, 24. And this is going to be 2 equals b. But to find a, we got to actually plug this in here. And at the same time, if you want, we can plug something else in here, like a 3. 36 minus 22 is 14 equals a plus b. 2, a equals 12. So now we're ready to integrate. 3 dx plus 12 dx over x minus 2 plus 2 dx over x minus 2 squared. This is going to be 3x plus 12 natural log of the absolute value of x minus 2. This is power rule. So this is going to be plus 2 x minus 2 to the negative 1 divided by the new exponent plus c. Final answer, I don't want negative exponents, so let's write 3x plus 12 natural log of the absolute value of x minus 2 minus 2 over x minus 2 plus c. There you go. It's a lot of good practice. Hopefully you guys are getting good at this stuff.